Welcome back, guys. We are here for 3.3. Just like 3.2, we are going to be applying inequalities to algebraic situations. However, we're not just going to add and subtract like we did in 3.2 for inequalities. We're going to be multiplying and dividing. So what types of problems are we going to be solving? Or we're going to be looking at inequalities like this. X over 2 is less than negative 1. Now, we looked at stuff in 3.2 where we added and subtracted, but just like we did in 2.1 and 2.2, I want to get x by itself. How do I do this? Well, just as addition and subtraction are opposites here, multiplication is the opposite of division. Again, you've seen stuff like this before. If I wrote down the equation, x over 2 equals 1, you would tell me multiply both sides by 2, and I get the answer, x equals 2. You handle the inequality the exact same way. I multiply by 2, I multiply by 2, cross out, and I am left with x is less than negative 2. Again, please interpret your answer in the context of the problem. I need you to know what this means. So what does x less than negative 2 mean? That means any number less than negative 2, if you plug it back into the original, will make the inequality true. So if I go ahead and do that, again, my solution was x is less than negative 2. What that means is if I plug in any number less than negative 2, like negative 4, for example, it should verify my inequality. Negative 4 divided by 2 is negative 2, which is in fact less than negative 1. Again, great way to check your work. Whatever you end up with, like x is less than negative 2, plug it back into the original or test some examples of that in the original inequality, see if it stays true. Now the other aspect of this, again, I did my work and solved this. I got x is less than negative 2. What we want to see going forward is I need you to also be able to create a number line with this. How would I create a number line? Well, again, flashback to 3.1. What I'm going to do is I'm going to get at least 5 lines on here. I'm going to identify my point of interest. Again, as I'm writing all this, please make sure you are writing all this down in your notes as well. Identify your point of interest, negative 2. The open side is facing the negative 2, so that means I'm going to the left since the open side is not facing the variable. And there is no equal to sign, so I will not be filling in the circle. Again, as I write all this, please copy it down in your notes. Pause when necessary. Okay, so we've done this. Let's do another example for you all. Let's say I had 3x plus 4 is less than 31. 3x plus 4 is less than 31. I want to get x by itself. What am I going to do? I'm going to subtract 4 from both sides. And just like I would do with an algebraic equation, left with 3x is less than 27. Divide both sides by 3. And I get x is less than 9. X is less than 9. What I'm going to do is 2 things. Number 1, I'm going to make a number line. But before I ever make that number line, I am checking my work. How am I checking my work? I'm testing a number less than 9 to see if it makes this inequality true. What's a number less than 9? 8. So I plug it in. 3 times 8 plus 4. Turns out to be 24 plus 4, which is 28. Is 28 less than 31? Yes, it is. Go ahead and create my number line here. Place a dot at my point of interest, 9. And I will be going off to the left. Why? Because the open side of the inequality faces the 9. not the variable, and I will be leaving it open because there is no line underneath. Okay, so we've done our example. There we go. Let's flip over to something new and do some error correction. You pretend to be me, I pretend to be you. Here's a problem I solved. I did this problem using the logic we've just been talking about, but I have made an error. I came up with the answer n is less than or equal to -9. So I want you to go ahead and pause the video and see if you can find my error. See if you can figure out where I messed up. Okay, so you've paused the video. You have figured out where I messed up theoretically. Let's see if we're right. Well, if you think I messed up with my algebra, I did not. I divided like -2 like I should. And 18 divided by -2 is -9. The -2's cancel. So I do have n is less than or equal to -9, but there is a problem somewhere in there. What I hope you did as a last resort, maybe you didn't, is go ahead and check my answer. I want you to plug a number that is less than or equal to -9 back into the original and tell me if it makes the inequality true. Okay, hopefully you've done this. I will try -8. That seems like the logical choice to me. Number less than or equal to -9. Okay, so I plug a number less than or equal to -9 in. And when I do this, I chose 8 or -8. When I do this and I multiply it out, I get 16 is less than or equal to 18. Okay, so we're going to do some error correction here. I want you to pause the video at this point, and I want you to look at, pretend to be me. This is my work. I want you to pause the video and see if you can figure out the error I made. Okay, you've unpaused the video. If you said there was an error with my algebra, maybe I shouldn't have divided by -2, or 18 divided by -2 is not -9, you are incorrect. My algebra is fine. So I hope the mistake you did recognize is, as a last resort, I hope you checked my work, as I've been emphasizing at the top here. I came up with a solution that n has to be less than or equal to -9. So pick a number less than -9. I'll go with -10. I know that seems weird, but remember, with negatives, the larger that number is, the smaller it actually is. What do I mean by that? -10 is less than -9. -15 is less than -10, and so on and so forth. So a number less than -9 is -10. Let's plug it back into the original equation. -2 times -10 is less than or equal to 18. When I multiply those out, I get 20. Hold up. 20 is less than or equal to 18. That is false. That's not true. So what's going on here? Well, I'm sure you have forgotten, if you cannot figure this out, the point that your previous math teacher about inequalities hammered home. And it is the following. When multiplying or dividing by a negative, we must flip the inequality. When multiplying or dividing by a negative, please do not forget to flip the inequality. Let's go through an example. If I have -5x is greater than or equal to 25, you all are immediately going to tell me to get x by itself, I need to divide by -5, and you're absolutely right. But when I divide by -5, I come up with the solution x is greater than or equal to -5. If you plug a number larger than -5 back into the original, like 0, for example, it will create a false inequality. So what you must do, because you divided by the negative, is flip that inequality around. This now will produce true math statements. If you don't believe me, pick a number greater than or equal to -5, my original answer that's incorrect, like 0, and pick a number less than or equal to -5, and my new answer after flipping the inequality, like -10. Plug them both back into that original inequality and see which one gives you the true answer. Again, the message here is multiplying or dividing with inequalities and algebraic situations is no different than what we did in 2.1 through 2.4. You just can't forget to flip the inequality if we divide or multiply by a negative. Okay, so let's go through another example. Again, if you want to test those numbers on your own, be my guest. Let's say we have -2/3 n is less than or equal to 2. I know you all hate fractions, but we're going to get really good at them because they are an important part of mathematics. So how is the -2/3 attached to n? Well, it is being multiplied by n. Again, n is neither in the numerator nor the denominator explicitly by itself. Therefore, it is not directly a part of the fraction. Therefore, the -2/3 is being multiplied by the n. Okay? So what are we going to do here? Well, we are going to divide by -2/3. Since -2/3 is being multiplied by n, we do the opposite and divide by -2/3. This will not only cancel the -2/3, but it brings down the n. I'm going to go ahead and flip that sign because I divided by a negative. And as you know on the chalkboard in the classroom, when we divide by fractions, we do not ask why, we flip the second and multiply. So what am I going to do here? I am not going to do 2 divided by -2/3, but rather I will be doing 2 multiplied by -3/2. When I do this, I get -6/2, which is the same thing as -3. Again, if you are someone who struggles with fractional multiplication and division, please come see me. I will happily help you. And how can we make sure this is true? Well, let's check our answer. A number greater than or equal to -3 is 6. I will try it back in the original. -2/3 times 6 should be less than or equal to 2. What is -2/3 times 6? Well, -2 times 6 gives me -12. Divided by 3 is less than or equal to 2. -12 divided by 3 is -4, which is less than 2. Again, we are getting the variable by itself the same way we've been doing now for a couple weeks. The difference is we just got to remember to flip that sign if it is indeed negative. All right, it wouldn't be a video lecture with Mr. Carter if we didn't have a wonderful story to close us out. So let us work through this together. The student council votes to donate the proceeds of a spaghetti dinner to Habitat for Humanity. The student council has allocated $216 for the purchase of spaghetti sauce to make all of the spaghetti. A case of jars of spaghetti sauce costs $13.75. How many cases can the student council buy? So they're donating the proceeds of a spaghetti dinner to Habitat. They allocated $216 for the purchase of the sauce. One case is $13.75. How much should we buy? Go ahead and set this up on your own and solve it if you are capable. If you are struggling, stick with me and follow along. If you're solving it on your own, pause the video right now. And then once you're done solving it, come check back in with me. Okay, so they've allocated, there are really two key numbers here, $216 and $13.75. 216 is the total amount we are allowed to spend on that spaghetti sauce. Okay? As you know, I always love finding the total first. And as a result, as you saw in 3.1, I'm going to determine where the sign goes. You need to ask yourself, can I have more than 216? Do they want me to be over 216? In which case, the open side will face away from the 216. Or do they want me to be under 216? If 216 is the maximum I can go, then the open side needs to face 216. Well, you should probably read again, and you're telling yourself they don't want any more than 216 spent, but I can spend 216 on the dot. Therefore, the open side will face the 216, and there will be a greater than or there will be an equal to sign underneath that inequality. Again, if this is confusing to you, please feel free to reach out to me at this point in the video, and I will help you work on determining your sign. So now let's work through the 1375. A case of jars costs $13.75. Well, easy enough. But the question is, how many cases can the student council buy? Well, the mistake that most people will make here is they'll put $13.75 plus C for the number of cases they can buy. But why do I not want to do plus C? Well, plus C would imply that it's $13.75 plus however many cases, but that's not the case. It's $13.75 per case. Therefore, it needs to be $13.75 times C for the number of cases. Okay? So this is how you should set up the inequality. Okay? So from there, we will go through and solve this. We obviously want to get the variable by itself, so we will divide by 1375, since that's what's attached to the variable. When we do 216 divided by 1375, 216 divided by 1375, we get a grand total of 15.709. And that's a rounded answer. Is greater than or equal to C. Now, what alarm should be blaring in your brain is, can I get 15.7 cases of spaghetti? Absolutely not. No, you can't. So what must we do? Well, though math tells us typically round up in this case, given the context of the problem, we must round down. Why? Because if we go over that 15.7, we will outspend our budget. Therefore, the maximum number of cases you could get would be 15 cases. In other words, if they buy 15 or less cases of the spaghetti sauce, they will stay in the budget for that habitat dinner. Okay? If any part of this does not make sense, feel free to reach out to me. I will be happy to help you. And that's 3.3.